All right, let's get right into it. We're all getting pretty comfortable with AI coding assistants, right? But what if the next developer on your team wasn't a person at all, but a completely autonomous AI? That's what we're digging into today, how we need to redesign our cloud systems, especially on AWS, so they're built for this next generation of AI developers. So here's how we're going to break it down. First, we'll nail down what we even mean by agentic AI. Then, we'll talk about the big problem, why our current systems are basically a giant roadblock for it. From there, we'll jump into a two-part solution, looking at both our system architecture and our code base. And finally, we'll wrap it all up with the key things you need to remember.
Okay, so let's start with the really big idea here. What on earth is this new world of AI that actually writes code?
I want you to just picture this for a second. You give an AI a high-level task, and it doesn't just spit back a few code snippets. No, it actually writes the entire feature. It creates the tests for that feature. It runs them, deploys the changes to a staging environment, and it validates that everything works, all by itself. That's the game we're talking about.
And that brings us to the official term, agentic AI development. The magic words here are rapid feedback cycles. The AI makes a change, it immediately sees the result, it learns from that result, and it tries again, over and over and over, at a pace that no human could ever possibly match. But there's a catch.
And that brings us right to the main problem we have to solve. Our cloud systems, the way we've built them for years, are a huge bottleneck for these AI agents. I mean, think about it, right? We designed all our systems for human workflows. We have these long deployment pipelines, manual testing gates, services that are all tangled up together. When an AI agent tries to work in that kind of setup, every tiny change kicks off this slow, painful validation process. It's kind of like asking a Formula One car to drive through rush hour traffic. It's just not going to work.
And this slide really lays out the difference. The way humans work is all about these big, infrequent, high-friction changes. But agentic development, it needs the exact opposite. It thrives on constant, low-friction changes and those super fast feedback loops. The old way of doing things is officially broken. And here's the absolute key insight. We can't just engineer better prompts to get out of this mess. The answer isn't about giving the AI better instructions. It's about totally changing the playground it operates in. We need an architecture where speed and clarity aren't afterthoughts. They're the main event. So, how in the world do we do that? Well, let's jump into the first part of the solution, architecting our systems specifically for that fast feedback. Probably the biggest change we can make is to have local testing be the default, go-to way to validate things. The AI agent has to be able to test its changes on its own, right there locally, in just a few seconds without ever having to wait for a cloud deployment. And the best part is, this isn't some science fiction concept. The tools are already here today. You can see AWS gives us local emulators for just about everything, from running serverless functions with SAM to spinning up a local DynamoDB and even running complex glue jobs. It's all there, ready to be used, making local testing a total reality. And the payoff is just huge. When you get local emulation right, you slash that feedback loop from what could be minutes or even hours down to a handful of seconds. That is the speed that unlocks agentic development. But of course, you can't test absolutely everything locally. It's just not always practical. So for those other cases, the idea isn't to avoid the cloud, but to use it in a really smart, lightweight, and targeted way. And that's where hybrid testing comes into play. So this looks like a few different things. For simple stuff like testing if a message gets to a queue, the AI can just deploy a tiny, isolated stack for a quick check. For bigger integrations, you can use things like API contracts to make sure the AI's code will play nice with other services before it's even fully built. And then, for that final check, the agent can spin up a whole temporary preview environment on demand, run its tests, and then just tear it all down. It's fast, it's clean, it's efficient. Okay, so we've made our system architecture way faster. Awesome. But that's really only half the story. Now we've got to look at the code itself. We need to structure it so that an AI can actually make sense of it and change it without breaking everything. The secret sauce here is creating super clear boundaries inside your code base. You have to pull apart your core business logic, the what your app actually does, from all the infrastructure code that wires it up to AWS services. And a fantastic way to pull this off is with a layered, domain-driven structure. See here, you've got a domain folder that is nothing but pure business logic. Absolutely zero AWS code allowed.
Then you've got an application layer that acts as the conductor. And finally, an infrastructure layer that does all the talking to things like DynamoDB or SNS. This basically gives the AI a perfect map of your code, so it knows exactly where it's safe to work.
Now, this next part requires a pretty big mental shift for a lot of us. In this new agentic world, tests have a brand new job. They're not just about quality assurance anymore. They are the main way you communicate what you want to the AI. A failing test basically tells the AI, nope, that's not it, try again, but do it this way. And that's why a layered testing strategy is absolutely critical. You need super fast unit tests for that core domain logic. You need contract tests to make sure different services are honoring their agreements. And you need smoke tests to catch all those sneaky permission or configuration bugs that only pop up once you've deployed. Each layer gives the AI a different, crucial piece of feedback.
Okay, we have covered a ton of ground. So let's bring it all home and boil it down to a nice, clear roadmap for your architecture. Really, it all comes down to these three core ideas. First, you have to prioritize fast feedback above almost everything else. Get those loops from minutes down to seconds. Second, create crystal clear boundaries. Use things like domain-driven design so the AI can make changes that are safe and predictable. And third, be explicit with your intent. Your tests, your docs, they all become the rulebook that guides the AI's behavior.
And when you really get this right, when your architecture is truly aligned with these agentic workflows, that's when AI agents stop being clunky assistants and transform into true force multipliers for your team. They can take over the tedious day-to-day coding, which frees up your human engineers to think about the really hard, high-level problems.
So that leaves us with one last question to chew on. Take a hard look at your own systems, your own deployment pipelines, your own code bases. Are they built for the developers of yesterday, or are they ready for the next developer to join your team, which just might be